a t-test. Okay, you're told that it's a t-test and you're comparing the different scores from two different classes. And it tells us that we're doing a two-tailed t-test. And that means that for the first part of the question, when we're writing down the alternative hypothesis, the alternative is going to be that the mean of the first is not equal to the mean of the second data set. Or you can write that as the mean of Manny's class is not equal to the mean of Annabelle's class. A two-tailed means that we're looking for both ends. So it's not just bigger than, smaller than, it's not equal to. And then for part B, you're asked to find the p-value for the test. So for this one, we again need our TI-84. And the first thing we're going to need to do is type in our data. Okay, so just deleting any data that might be there. And we're going to type this data in, so 76. Okay, so now I have my data written in. And I can find the p-value. So I'm going to go to statistics and tests. And this time I have a 2-sample t-test. Now I'm interested in using the data, which means that I have the original data. The first list is in list 1, the second list is in list 2. I now need to change or decide which null hypothesis I want, and I want them not equal to each other. You must always select yes for pooled. This was the biggest reason that people go wrong. So yes for pooled, and then we are going to calculate the information. And we can see there that the p-value is equal to 0.97652 to 5 decimal places. So it does ask for 5 decimal places. It is worth 2 marks. 1 mark is for the answer and 1 mark is for 5 decimal places. So you can see if you were to cut it off here, after the 5 places, the 6 will move this one to a 2. And then part C says that you need to decide whether or not you reject the null hypothesis or whether you accept it. So Annabelle concludes that there is no evidence to reject the null hypothesis, and we need to decide if that's true or false. So the data that we're looking at is 97%, and the significance value is only 5%. Okay, so the p-value is very, very large. It is not close to being unaccepted, and therefore H0 should be accepted. So H0 should be accepted. And therefore Annabelle is correct. Okay, so Annabelle is correct. And if you need to give a reason, then you can have that the p-value, which is the 97.6%, is much bigger than the significance value, which is 5%. Okay, and therefore Annabelle was correct in saying that the H0, the null hypothesis, is to be accepted.